equilibrium of a particle in 3D. Objectives: draw 3D free body diagrams, and develop scalar equations of equilibrium from 3D free body diagrams and solve 3D equilibrium of a particle problems. Really, the idea is, 3D problems being hard for us to visualize, to draw. Perspective can mess with you like an M.C. Escher sketch. The fellow was walking up the stairs, and before you know it, he's upside down on another set of stairs. We can be misled visually by what's printed on a page. So it's kind of hard to work with 3D sometimes. And so as soon as it becomes hard for us to visualize, that's when we move to 3D vector approach, and we just go ahead and buy into it all together. We convert all of our vectors into Cartesian vector form with i's and j's and k's, and then build our equations there. And at the very end, we'll develop scalar equations of equilibrium and solve the problem the old-fashioned way. When a particle is in equilibrium, the vector sum of all forces on it must also be in equilibrium or equal to 0. And that's the same as it was for 2D. But here we're going to kind of make sure we expand on this into the 3D concept. We now know that because all of the x components of all of these vectors are what are going to go into I, and the y components are what are going to go into j, and the z components are going to go into k, that we know that what we could do is write it in vector form like this: the sum of forces in the x times I plus the sum of forces in the y times j plus the sum of forces in the z times k is equal to 0. But what that really helps us with is that now we actually know that we can take all of our I terms, take all the I terms for all the different vectors, and that should equal 0. Do all of these coefficients, take all your j terms, put them in a sum of forces in the y equation, set it equal to 0. And then we're going to take all of our z coefficients from our vectors, all of the k terms, put them in a scalar equation equal to 0. So this is where we're turning it into a scalar problem. We're going to break it up into x, y, and z. We're going to get rid of the i's and j's and k's. They served us for a while there. We did it for all these vectors. We get i's, j's, and k's for all the vectors, and then we build our scalar equations of equilibrium, and then we solve it using algebra. Since there are 3 equations, we can solve for up to 3 unknowns. If there's 4 cables here or 4 unknown values, you're out of luck. Too many to figure out. It's not that it's not stable. It's actually more stable. We'll talk about that later in the year, but it's just something you cannot solve with statics because you only have these 3 equations of equilibrium. 3D free body diagrams. Okay, this is really the exact same thing as I said before. My 3 rules are: you keep the part you're keeping, you get rid of the parts you're getting rid of, and at any cuts, you replace the parts you cut away with the internal force vectors. Here we're going to take a free body diagram of particle A here, and you can see here's my free body. Okay, I now have tension forces all acting away. I mean, there could be compression forces, but right now we're still kind of keeping it simple with tension forces. And it works the exact same way as 2D. The problem here is that it's really kind of hard to visualize it, right? Again, a lot of times problems kind of have these visual clues. I tried to draw some orthogonal lines here so you kind of see now you can see that D is actually coming out towards us. C is going into the page away from us. AB is sitting right there on the z-axis. Is actually pretty easy to see. And W is acting straight down on the negative y. And that's all great. What we do here when we have trouble visualizing, we turn it into a full-fledged 3D problem, is go ahead and calculate all the i's and j's and k's for all your vectors. Write them all in I, j, and k term. All of them. And then just collect all your i's and put that into your x equation. All your j's put in your y equation, and all of your k terms and put them in your z equation. That means even these easy ones. Okay? All of them. So I'm going to work an example of this problem here in a separate video. So check that out. And I think then you should have a pretty good grasp of equations of equilibrium for 3D particles. Thanks for watching.